Hello, everyone. Welcome back again to our lecture series, Resultant of Two Concurrent Forces. Kindly subscribe to our channel, share and like as well, and also don't forget to leave comments at the comment section. Our previous lecture was on resultant of two concurrent forces. So this video is the second part. We saw some examples, and in this video, we are going to continue with solving problems on the resultant of two concurrent forces. So let's quickly run through. Example number 3. The resultant of two forces has a magnitude of 900 newtons. Determine the direction of the resultant from the positive x-axis and the magnitude of the force K. Don't forget that you have already established the fact that anytime you are given two concurrent forces acting on an object and you are asked to find the resultant, you can either use the method of summing components, that is resolving the individual forces to the x component and to the y component, and then finding the resultant, or you can use the law of parallelogram in addition with the triangle rule. So for this question, we are going to use the law of parallelogram and the triangle rule. So let's see how we can be able to solve such question. Solution to example 3. So as you can see from this question, first of all, we need to draw our free body diagram to represent what is in the question. So we are given that from the question, we are given that we have two forces. So this is our axis. This is our axis, our x-axis. And then we are told that we have a force coming down here. And then we are told that the magnitude of this force is 400 newtons. 400 newtons. And then in the same way, we have another force coming in this direction. We have another force coming in this direction. And then this one, we are told that this force is called K. This force is K. And then we are told that the angle from the x-axis, so this is our x-axis, the angle from the x-axis to the force K is 35 degrees. It's 35 degrees. And then the angle between the two forces is given as 55 degrees. So if you have this question, the first thing we need to do is to complete our diagram to form a parallelogram. So let's try and complete our diagram to form our parallelogram. As you can see on the screen, we want to form our parallelogram. Good. So once you have been able to form the parallelogram, if this, we know that the opposite side of a parallelogram are equal. So if this is 400, this side will also be 400. And if this is K, this side will also be K. And then we know that the opposite angles of a parallelogram are equal. So if this side is 55, this side will also be 55. Also be 55. Good. So in this question, what you need to do, our resultant will be the diagonal of our parallelogram. Our resultant will be the diagonal of our parallelogram. So our diagonal will go that way. Our diagonal, sorry for that. Let me try and then get a nice diagram. our diagonal is going to go from this point up to this point. This will be our diagonal. So for our diagonal divides the parallelogram into two equal triangles. So we can just, let's take this side, which is A of the triangle A. Let's take that this side is B. So let's take this side of our triangle. So now we can also draw again a free body diagram for that triangle. So that triangle will look like this. This is our x-axis. And if that is our x-axis, we know that our diagonal will go that direction. Our diagonal will be at this direction. And then we have our first force coming this way. We have our first force coming that way. Sorry for that. So our first force will be moving in this direction. Good. And then our other force will join at this point. Will join at this point. Good. So we know that the angle here is 35 degrees. We don't know the angle which is here. So let's represent it with any other thing. Let's say alpha. We don't know the angle which is up here. So we can also represent that with, let's say, beta. But we are told that the angle between, so this is our resultant, R. Then this side is our 400 newtons. And then this side is the K, our force K. But we know that the angle between K and our 400 newtons, the angle between our K and the 400 newtons is 55. So you can see clearly that it is not this angle, because from the diagram, you can see that this angle is more than the 55. So it means that that angle is at this side. That angle is at this side. That angle, which is given as 55, is at this side of the triangle. So the angle here is 55. The angle there is 55. So we know that if this is 55, then let's take that this angle inside here will be x. This angle inside here will be x. But we know that the angles form on a straight line. So we have been able to represent our ends on the diagram. But we know that angles on a straight line, angles on a straight line add up to 180. So we can say that our x plus 55 will be equal to 180. So from there, we can see that our x will be equal to 180 minus 55. 180 minus 55, which will give us 125 degrees. So we know our x here, our s is equal to 125. So if we can draw it nicely, now we can see that our diagram will look like this. Our x-axis is like that. Our resultant will be here. Now let's take it that our K will also be at this side. And then this side will be our 400 newtons. This side will be our 400 newtons. So if you can be able to join this to that, that is our resultant. Good, sorry, it is not straight. So our resultant will be from this point coming to that point. So we know that the angle here is 35. The angle here, we said that we are calling it alpha. The angle here, we said that it is going to be, from our calculation, it's 125. we know this side will be K, this side will be 400 newtons, this side will be beta, we don't know that angle, the angle for the 400 make with the resultant, we don't know. And then we know that the angle here is 55. And then this side is our R. Good. So now we are given that the resultant from the question, we are given that the resultant is 900. So from here, we know this angle, we know this side. So if we are asked to find the angle which the resultant make with a positive x-axis, then our angle is going to be from this point up to that point. Let's call it theta. So from here, we can clearly see that our theta will be equal to 35 degrees plus our alpha. But we don't know alpha from this question. So let's try to calculate alpha. How do we get alpha? We know from the sine rule that if we know this side, then we can say that this side over the sine of this alpha will be equal to, now we know this side and we know the opposite angle. So we can use that. So this side, this 400 over the opposite angle will be equal to our resultant, which is 900 over the opposite angle. So from here, we can say that sine, our A part of the question, sine alpha over the opposite side, which in this case is 400, will be equal to our sine 125 over the 900. And from here, we can make alpha the subject. So we can say that sine alpha will be equal to sine 125 over 900 times 400 times 400. And from here, we can say that our alpha will be equal to the sine inverse of sine 125 over 900 times 400. And from here, we can easily get our alpha, where our alpha will be equal to 21.4 degrees. But don't forget that we have stated that our theta, which is the angle the resultant make with a positive x-axis, is alpha plus 35. So it means that our theta, which is the angle the resultant makes with the x-axis, will be equal to 35 plus 21.4. And then our theta will be equal to 56.4 degrees. 56.4 degrees. Good. So having been able to do that, we can now, this part of the question, we were asked to find the magnitude of the force K, and then we know that K is this side of the diagram. K is this side, which we don't know. So we can as well use the sine rule. But before we use the sine rule, don't forget that we said that it's this side over the opposite angle, and we do not know this angle. So first of all, we need to calculate this angle from the question, and then from there we can say that the part of the question, we can say that alpha plus 125, sum of angles in a triangle is equal to 180. So plus beta will be equal to 180. But we know alpha, which is 21.4 plus 125 plus b will be equal to 180. So from here, we can say that our beta will be equal to 33.6 degrees. Once you have been able to calculate our beta, then from there we can be able to calculate for our K. So we can say that K, this side over the opposite angle, will be equal to the resultant over the opposite angle. So here we can say that K over sine beta, and we know that beta is 33.6, will be equal to our resultant, which is 900 over the opposite angle, which is 125. So from here, we can say that our K will be equal to 900 over 125 times sine 33.6. And from here, we can easily calculate our K. Our K will be equal to our K will be equal to 608 newtons. Our K will be equal to our 608 newtons. And our angle theta is 56.4. Good. So that was pretty simple. Let us now move to our next question. If you have any comment or anything which you didn't understand in this session, you can let us know at the comments. You can let us know at the comment session. You can let us know on the comment section, so that if there is anything which you also want to add to what you have done on this question, you can also give us your suggestion, even as we move on to the next question. So the next question, example 4, two forces of magnitude 320 newtons and M are applied to a boat at A. Calculate A, the magnitude of M, if the resultant of the two forces applied at A is to be vertical, B, the corresponding resultant force. So in this question also, we are going to use our laws of parallelogram, So, and in addition with our triangle rules. So let's see how to go about this question. Solution for example 4. So in this question also, we have already established the fact that anytime you are given the question, try to represent the question in the form of a free body diagram. So let's quickly try and draw a free body diagram for our question. Question 4 is what we are solving. So let us try and draw a free body diagram for our question. Good. So we have our x-axis like this, and then we are told that there is a point here called point A, and then for this point A we have two forces. One is going this way, and then we have another force which is going that way. And then we are told that the angle here is equal to 25 degrees from the question. And then we are also told that the angle here is 30 degrees. It's 30 degrees. The angle here is 30 degrees. And then we are asked to find the magnitude of M if the resultant is vertical. So if the resultant is to be vertical, it means that our resultant is going to be straight up on the y-axis. Our resultant is going to be straight up on the y-axis like this. This is going to be our resultant. So let us try and then complete this diagram to form our parallelogram as we always do. So when we try to do that, we can draw this side to meet our resultant. And then we can also bring this side to meet our resultant. And also draw from this side to meet the other. Good. So having been able to do this, and now we know that the angle, if this is to be vertical, it means that it will be on the y-axis. And then we know that the angle between the y-axis and the x-axis should always be 90 degrees. So if this is 30 degrees, then this angle here is going to be 60 degrees. It's going to be 60 degrees. And if this angle here is 25, then this angle is going to be, 55. Then this angle is going to be 55. Good. But having done that, now since we want to take one side of our triangle to do the analysis, we don't know the angle here, we don't know the angle here. So what we do is that we try to draw a straight line in between the two. We try to draw a straight line like this with the dotted lines. Good. So from here, you can see that this side of the diagram, forms something like a Z with this side. It forms something like a Z. You can see that this is a Z angle. And then we are told that Z angles are equal. So if this side is 25, then this side is also going to be 25. Right. And then we know that this side will also form a Z with this side. So if this is 30, then this side is also going to be 30. Then this side is going to be 30 degrees as well. And then this is 25, this is 30. And then we can also see that when you consider this side, if we consider this side, we can also see that it forms Z. So if this side is 25, then this side will also be 25. This side will be 25. And if this side is 30, this side will also be 30. Good. And we are told that the magnitude of this side is 300. The magnitude of the force at this side is 300. And this side is M. And we know that opposite sides of a parallelogram are equal. So if this side is M, then this side is also going to be M. And then this side is also going to be 300. So having been able to do this, let us now represent our diagram using just half of the triangle, considering our resultant. So here we can see that if our resultant is vertical like this, then it means that our 300 force, which is pointing upwards. So now our x-axis will be on this plane like this. This will be our x-axis. Our first force will be like that. And then our other force will be like that. This in this direction, this also in this direction. And then now we have already seen that the angle here is 30. The angle here is 25. The angle here is also 30. And the angle between the 300 newtons and the resultant is 60. Between the resultant is 60. Good. And then we are given that, sorry, the angle at this side was given as 320. It was given as 320. So this magnitude is 320 newtons. Good. So and this side is our M. This side is our M. So having been able to do this, we can be able to get the angle here. So let's take it that our angle here is beta. Our angle here is beta. If our angle here is beta, then we can say that our beta plus, this is 25 plus 30. So 25 plus 30 plus our 60 will be equal to 180. So from here we can see that beta will be equal to 180 minus 60 plus 55. 180 minus 60 plus 55. And then we can say that our beta will be equal to 180 minus, this will give us 115. So our beta will be equal to 65 degrees. In the same way, if you don't want to use that method, we are told that this side of the angle is 25. So we know that this is 90. If this is 25, then this side is going to be 65. This side is going to be 65. So you can also see that, you can see that the angle between M and the resultant is 65. So in that case, you can also represent it here, that the angle here is also equal to 65. That is another way of finding that angle. And then from here, we can calculate our M, because we know this side, we know the angle here, we know the angle here, and then we are asked to find the magnitude of this M. So we can say that M over sine, the opposite angle, sine 60, will be equal to what you have been given, 320 over the sine of the opposite angle, which is beta, so sine 65. And from here, our M will be equal to 320 over sine 65 times sine 60. And from here, we can say that our M, will be equal to 305.8 newtons. Good. We are also asked to find the resultant, the magnitude of the resultant. So in this case, this will be our resultant. We know the angle here, which is facing the resultant, and we know this side and the angle here. So we can as well get that. We can say that R over the opposite angle, which is 25 plus 30, which will give us sine 55, will be equal to what you have been given, which is 320 over the opposite angle, which is beta. So here we are going to get 320 over our beta, which we are saying that is 65 degrees. So therefore, we can say that our R will be equal to 320 over 65 times sine 55. And from here, we can say that our resultant will be equal to 289.2 newtons. Good. So this question was also very simple. If you have any challenge with this comment or any comment, you can also leave it at the comment section. Good. So let's now try to solve our last question. For this tutorial. Let us try to solve our last question. So our last question, example 5. 2 wires are tied together at point P to support a load of 600 kilonewtons as shown. Determine the tension A in cable MP, B in cable NP. So let's try and see how to solve this question also. Try to see how we can solve this question. Solution to example 5. Good. So we said that always you draw a free body diagram. So in the question, we have been given a plane like this, and then we are told that we have point P, and then point P, this is point P. We have another point which is N. We have another point which is N. And then we have another point here which is M. All meeting at point P. So this is M. And then we are told that the angle here is 35 degrees, and the angle at this side is 52 degrees. And then we are holding a 700 or a 600 kilonewton weight. The two cables are holding this weight. So it means that now from this question, the first thing you need to understand is that our 600 kilonewtons will be our resultant force. So we can draw our axis to pass through this point like this. And then we are saying that our 600 newtons will be our resultant force, which will be moving downwards like that, will be our resultant. So this will be 600. Good. So we know that from this side, we are forming a Z angle, and we know that Z angles are alternate angles and they are equal. So if this is 35, then this side will be 35 also. And this is also forming a Z angle. This is forming a Z angle. So if this is 52, then this side is also going to be 52 degrees. Having been able to do that, now we know that this is a straight line. Our resultant is a straight line, it's vertical. So, and we know that the angle the vertical makes with the x-axis is 90. Therefore, if this side is 35, then this side is going to be 55. And if this side is 52 at this side, if this side is 52, we are told that this angle is going to be 90. So if this side is 52, then this angle is going to be 38. This angle is going to be 38. Good. So having been able to do this, then we can just pick one side of the triangle and do our analysis with it. So I pick the side of the triangle. So we can as well complete this to form a parallelogram. So it means that it will be something like this, and something like that. So it means that this side will be our N and this side will be our M, and our resultant will be positioned like this. Good. So now let's pick one side of the triangle to do our analysis. So we pick our resultant like that, and then we know that this side is N and this side is M. And from the question, from this analysis, we know that the angle, this is our resultant. The angle between the resultant and M. So this will be P, this will be MP, and this side will be NP. So this will go this direction, while this go this direction, and that goes this direction. Having been able to draw this diagram, we know that our angle here is 55 degrees. The angle our M makes with the resultant is 55. We also know that the angle our N makes with the resultant is 38. So we can also represent our 38 here. We don't know this angle, we can represent it with X. But we know the magnitude of, we don't know MP, and then we don't know NP, but we know the magnitude of our resultant, which is 600 kilonewtons. So from here, we can be able to find our X. We know that the sum of angles in a triangle is equal to 180. So from here, we can say that X plus 38 plus 55 should be equal to, it should be equal to 180. It should be equal to 180. So from here, our X can be determined. Now X will be equal to 180 minus 93. And then our X will be equal to 87 degrees. So having been able to determine X, now we can use our sine rule. From our sine rule, this side over this angle will be equal to this side over that angle, and the same for the NP. So first of all, let's determine the NP. So the NP, we can say that NP over the sine of the opposite angle. Here, the sine of the opposite angle to the NP is 55. So over sine 55 will be equal to our 600 kilonewtons over the angle X, which is 87. So sine 87. So from here, we can say that our NP will be equal to 600 over sine 87 times sine 55. And from here, our NP will be equal to 369.9 kilonewtons, 0.9 kilonewtons. We can do the same for the MP. So for the MP also, we can say that MP over the sine of the opposite angle, which is 38, is equal to our 600 kilonewtons over the sine of the opposite angle, which is now 87. So from here, we can say that our MP will be equal to 600 kilonewtons over sine 87 times sine 38. And from here, our MP will be equal to 492.2 kilonewtons. So we are done also solving this question. If you have any problem or any challenge, you can let us know at the comment section. So this brings us to our questions for this session. Thanks for watching. Kindly subscribe to our channel and also hit the notification bell so that whenever we upload a new video, you can easily get in touch with us. See you in our next video. Bye-bye.